Woohoo! It's a great day to learn some geometry. I'm Miss Leg Battles, and I'm here today to talk to you about equations of circles. First of all, we know that an equation of a circle means that every value that we can plug in for x and y would be a point on the circle. So let's see how we would come up with that. First of all, let's let this point on the circle be that generic point xy. Stands for any point along the circle. And it's standard for us to represent the center with HK. So this is the center of the circle, is the point HK. Now, let's draw in the radius here. Let's do that without arrows. There we go. And that's going to represent the radius. And let's see if we can write an equation. Well, first of all, oh, you're going to love this. You know, this is going to look very Pythagorean-ish. We'll just make a right triangle here. And let's represent this point down here. Okay, how far did we go to the right from the origin to get here? Well, the same as I did for the point xy. So that's going to have x coordinate x. And the y coordinate, how far up did I go? Well, I went the same distance up that I did for this point hk. So that means the y coordinate is k. Now, let's Pythagorize, okay? R squared is going to be equal to, because R is the hypotenuse, okay? Whatever this length is right here, okay? The x's are the same because it's on the same vertical line, so we can find that length by just subtracting the y coordinates and taking the absolute value. Same thing here. What can we do here? Notice they have the same y coordinates, so to get that length, we can subtract the x coordinates, x minus h, and really it's absolute value. But notice when we put that in, when we put in x minus h, the absolute value of that, into the Pythagorean theorem, remember the Pythagorean theorem, c squared equals a squared plus b squared. When I substitute that in, I've got absolute value bars, but then I square it. So we realize that's kind of redundant. So this other value is the y minus k squared. So we, as it turns out, we really don't need the absolute value bars, because once we square that, then it's going to be positive anyway. So there's no need to make it positive before we square it. Now, hopefully this looks very familiar to you, okay? So this is beautiful. We've derived the equation of a circle. R is the radius. R is radius in my equation. And the center is HK. That's the center. Now, this looks familiar because we did this exact same thing before. We derived the distance formula the same way. You know, it turns out Pythagorean theorem, distance formula, equation of a circle, it's all just the same thing. You know, if I took the square root of both sides here, we would get r equals the square root of x minus h quantity squared plus y minus k quantity squared. Would look very much like the distance formula. The radius is the distance from the center to a point on the circle. Let's look at an example from the homework set. We're to find an equation of the circle that have center negative 9, 5, and radius square root of 6. So let's remember our formula. The formula is r squared equals x minus h squared plus y minus k squared. Or I can see from my choices over here, they have the r squared on the right. So we can do that. It really doesn't matter which side it's on. So let's say the center is the point HK and radius is r. All I have to do is substitute in for these. So I get x minus a negative 9, that's going to be x plus 9 squared plus y minus 5 squared equals the radius, which is square root of 6, squared. You know, the square root and the square are going to undo each other, and that's just going to give me 6. Or you could square it. You got the square root of 36, which again is 6. Now, it's very easy to look over here and tell which one is my answer. It's going to be C. C's the correct answer. But you know, this is a great opportunity to talk about being good multiple choice test takers. And the first thing I notice is, remember in our equation, because of the minuses in the equation, the sign's going to be opposite. If the x coordinate of the center is negative 9, it's going to be x plus 9 here. So I know that it can't be A and it can't be D because they start with x minus 9 quantity squared. So it only leaves B and C for the choices. So remember, it's r squared, not r by itself. So see, this was just r, not r squared. This one is r squared. So that's how we know it's the correct answer. This problem asks us to write the standard form of the equation of the circle with the graph that's shown. Now, again, we need our general formula, x minus h quantity squared plus y minus k quantity squared equals r squared. To write an equation for a circle, we need the center, okay? The center is negative 5, negative 1. And the radius is 1, 2. The radius is 2. So, let's substitute that in. That's going to be x minus a negative 5, which is plus 5, plus y minus k, that's y minus a negative 1, y plus 1, equals r squared. If r is 2, 2 squared is 4. So here is the standard form. Now, one thing that I added here is this little symbol. I put this in because when you're working in Math Excel, if you will click on that, it's going to make the graph nice and big like the one I have here. And I almost left this without my squares on there. Oh my goodness. There we go. X plus 5 quantity squared plus y plus 1 quantity squared equals 4. Let's look at this example. Find the equation for the circle with center 1, 2. Remember, center is HK. And passing through this point. This is a point on the circle. So it's actually the XY, or one set of the XY. Now, to write an equation, we need two things. We need the center and the radius. So when we start writing our equation, we have x minus h is 1, quantity squared, plus y minus 2, quantity squared. And I'm going to have to figure out the radius. But you know, again, talking about being good multiple choice test takers, we know that the answer cannot be B or C. It's going to have to be A or D. It's the only one that has the center correct. So we've just got to figure out what the radius is. So think about what this looks like. I have the center and a point on the circle. The radius is the distance between those. So we can use the distance formula on that. But you know what else? We could just use our equation of the circle. We could use our x minus h quantity squared plus y minus k quantity squared equals r squared. And we can find r when we substitute in this point on the circle here, this negative 2, 3. We can put in negative 2 for x, and we can put in, of course, 1 for h. And then y is 3 minus k, which is 2. And that gives me negative 3 squared, which is 9, plus 3 minus 2 is 1, squared is 1. So r squared is 10, and now, come to think of it, I really don't even need r. I do need r squared in my equation. So that's going to be 10, and now I see my answer is D. And that brings me to our last example. Find the center and radius of the circle and then graph the circle. So I can read the center and radius right off this. I want to remind you that my equation is x minus h quantity squared plus y minus k quantity squared equals r squared. So matching that up, I notice my center is negative 4, negative 3. Now remember, the signs are going to be opposite from what they are in the equation because of the minus in our formula. So if I substitute back in this part, it would be x minus a negative 4, which gives me my x plus 4, and then of course quantity squared, and so on. So r squared is 4. Okay, that means r is 2, not plus or minus 2, because radius is going to be positive. So once I have my center and radius, I can graph it. That's all I need to graph it. And here it is. This is a circle with center negative 4, negative 3, and radius 2. I hope this has been helpful. It's been great to be able to help you today. I hope you do well on your equations of circles. Have a great day.